So the question is basically, is opinionated a bad thing for DevOps tools? And simple question, yes, no. And we're going to go through and talk about that. Yes, it's a loaded question, and I have opinions on it. So let's go ahead and get kicked off. Let me get my cursor on the right screen here. All right, so quickly, for those of you that were not in part one, I am Jason Lance. I'm the founder and president of MuseLab. I've been working in ISV DevOps for about 10 years. I started and led the Salesforce.org's release engineering team for about 8.5 years. We created a whole suite of tools, which we're going to talk about today. So brief summary of me. Now, to the poll question. I hear this a lot when I hear people talk about different tools, Cumulus CI and other tools kind of in the ecosystem, that, it's just too opinionated. And, essentially what the formulation that I see here is that opinionated is a bad thing. And what I find interesting about this is that's actually just an opinion, right? The problem with opinions is not the opinions. The problem is bad opinions. So bad opinions are bad. And we can all agree on that and move forward. So I think the question is, what opinions can we learn from kind of experience in building this stuff out? What are the best practices that we can find so that we can form good opinions and build tools and tooling products that bake in those good opinions and help people use them? Along those lines, I was a debater in high school and in college. I love the concept of debate as a way of formulating better ideas and fusing different points of view. So I think this goes along naturally with opinions. There's a blog post out on the MuseLab blog about how you foster a culture of debate in engineering teams. We did this in my team at Salesforce.org. It's a lot of the reason that our tools kind of became what they are is because we had this vibrant culture of debate throughout the team. So I want to quickly recap a couple of the concepts from our session or from the session last week, because we're going to be talking about basically the tooling and the process that implements these concepts today. I'm not going to cover these in extensive detail. I just want to highlight a couple of key points from the last time, just to recap, and for those that didn't see the last one. So the first is this fundamental disconnect that ISVs face. ISVs think that they have their package source in version control, therefore they have their product in version control. In reality, their product is made up of their package installed into an org and a whole bunch of extra configuration on top of it. That is the thing that turns the package into something that's usable, that you can test and demo and everything like that people can actually use. So the product delivery model, which was introduced last week, is basically just a new model other than the package development model and the org development model in Salesforce, that just redefines what it is that the product of development actually is. So in the product delivery model, the product is an automation recipe and version control used throughout the product lifecycle to deliver complete product experiences to new or existing orgs. That means that the automation is part of the product. Features aren't done until the delivery automation is done. And what we're going to be talking about today is you're going to be, to implement the product delivery model, you wind up investing a lot of engineering effort into these recipes. So what we're going to be talking about today is kind of how you can build those recipes using tooling that allows them to be composable and portable, so you can apply them to different user experiences throughout the process. And when we talk about delivering a product experience or a product experience recipe, we're talking about, and we'll dive into kind of a more concrete examples using Cumulus CI of how you do some of these things in your recipe. But this is what we're talking about at a high level, is how do you automate all these different layers that make up a complete experience of a product? And you can see it's a lot more than just the package that you're developing as an ISV or as an ISV product development team. And the last kind of concept recap from last week is the disconnect and the DevOps problem that is encountered by this disconnect between the package and the product that the product delivery model aims to address. So the left side represents what most ISVs experience with the package development model. Devs are working in scratch orgs that are very isolated. They don't represent the actual product. And the rest of the business is all focused on a handful of orgs that really represent the source of truth for the product, not version control. Versus in the product delivery model, the entire recipe for delivering the product lives in version control, and anyone can self-service to create their own environments as they need, unlocking parallel development, scalable development, and everything like that. So that's our goal. That's what we're talking about today, is kind of the tooling and the process for how you build that reality. All right. I'll jump back a little bit into concepts and theory a little bit again, but this is concepts and theory specifically about tooling. This slide was largely inspired by an amazing blog post that David Reed just wrote and put out there called On Creating Automation Products that he credits me for inspiring. It definitely takes my ideas and extends them way beyond and in far more detail. But if I want to summarize kind of the distinction that I see here, I think when people start with DevOps, they start with scripts. They build a script to accomplish a specific task in a specific context for an operator. So an operator, even an automated build process or a person, needs to be able to run this specific task in this context and make it work. Tools, on the other hand, are help accomplish a set of tasks in various contexts for skilled users. So people that know how to use the tool can accomplish those tasks. Products kind of extend that beyond and really aim to focus on the user experience. In DevOps, I would say a DevOps product is focusing on automating and monitoring the repeatable processes for all stakeholders. So it's not just for skilled users. You're setting the bar much higher for user experience and who you're trying to engage in the product. So when you think about kind of what are the hallmarks of a DevOps product versus a script versus a tool? These are examples on the screen here from Cumulus CI. If you look in the Cumulus CI repository, there's a very robust build process that does lots of test builds against sample project repositories. And there's, I believe, 95% automated test coverage that gets run on every commit. So it's not just a tool that was built to do something. It's built like a product. It's built with the same engineering muster that you would put into building a product and the way of thinking about it. And then the kind of tooling that we're going to start with today is a layer on top of Cumulus CI called D2X. And the goal of D2X is to build a bridge between isolated package development and org development so that anybody can develop like an ISV when needed, and ISVs can define and automate the entire delivery and upgrade process for their products. So we're trying to build that middle ground between that isolation and the whole org, kind of swallowing the elephant whole kind of analogy. And when we built D2X, a little bit of the story of where D2X came from. I was working with one of my ISV clients, Risk Connect, who I'm giving a Trailblazer DX session. I have a more info on that later about the story of the implementation that we've worked on together over the last 7 months. And essentially their project was 15 managed packages with 5 layers deep of dependencies, and they're released as a mix of 1GP and 2GP based on the package. So a really complex environment. What I found was I was going to have to duplicate a lot of work from every repository. So that led to the creation of D2X, which is basically a baseline layer for implementing the best practice process that we're talking about today, that's totally open source and available to anybody. The goals of D2X are to be really easy to launch, develop, and deliver a project, to be efficient to operate that project and release it over time, and to be extensible by bundling all the best pre-configured tools to help you automate everything. Along with that, we built a product called D2X Launchpad. This is a free tool that MuseLab hosts just for the benefit of the community to make it easier to get a project going with D2X Launchpad. I can go ahead and show you an example of that here real quick. We'll go ahead and go to D2X Launchpad. I'm going to log in with GitHub. And I'll go ahead and select the MuseLab D2X. I'll make this repo public. Let's call this ISV webinar demo to be a little bit more specific. I want to do more webinars. So now I can pick what type of project I want to build. In this case, let's go ahead and build a 2GP managed package, and I'll put it in the D2X namespace. And one of the things that's really cool is that you can build on top of other packages. So I just did a session at CactusForce last week and added the package that I used there. So I'm going to go ahead and say I want to create this repository, building a 2GP managed package project, extending another project, I'll go ahead and confirm this. I'll list it here so that you can look it up easily on Launchpad in the future. This is going to ask for permissions for more extended permissions to GitHub. So it only uses these permissions temporarily and revokes them when they're done. We were really particular about planning it that way. We don't want access to your GitHub long term. We just want to help you along. So now I've got a link to go view my repository. I have a repository that's set up with beta, feature, and release build workflows for me automatically. It's got a Cumulus CI YAML. So this is a ready to go project that I can go in and start developing and has the entire CI/CD process that we're going to be talking about baked into it already. The other thing that it has is a pre-built configuration for dev container, and that works with GitHub code spaces. So for instance, if I want to launch a new dev environment for this project, I already have some secrets set that I need, so I just need to associate them to this project. Then I hit create code space, and this is going to launch a VS Code instance in the browser that has all the versions of tooling that are specified in this project's configuration, using a Docker image that's the same Docker image my CI/CD builds are using. So you have alignment between dev environment and build environment for the first time. So lots of really cool things, pre-wired setup. It's really easy to get going with. And you get essentially what I'm delivering to my ISV customers for each of, what I'm helping them kind of backport to their existing projects for any new projects for you that you do. All right. Now, the architecture of D2X and kind of GitHub. At the base layer, D2X is actually a very thin layer. It's a Docker image at its core that bundles SFCLI, Cumulus CI, and has automation set up to be able to handle environment variables for a dev hub, a target org, or a packaging org, auth URL. And then there are GitHub Actions standard workflows for different types of builds so that your repo doesn't really have to have a lot of logic in the individual build files themselves. And those are workflows that we maintain as part of the work that we're doing with our ISV clients. So that's all available to you. It's open source. And then in your project, you're defining all the layer of uniqueness for your project that needs to happen and inheriting all of the process from D2X. So D2X is essentially a way to get Cumulus CI's process up and running in GitHub really easily. So probably helps to understand Cumulus CI's process a little bit. So a little bit of background about Cumulus CI. The Cumulus CI documentation is actually really great. Our team spent a lot of time on that, working with a professional doc writer to really make sure that that documentation is as approachable to people as possible. That documentation sums up Cumulus CI as Cumulus CI helps development teams build great applications on the Salesforce platform by automating org setup, testing, and deployment, which I think is a pretty good summary of what Cumulus CI is. It's open source. It's a framework that's built in Python, and there's a command line interface for automating delivery that's built by Salesforce.org, originally to support nonprofit cloud and education cloud, and now as part of Salesforce Industries and supporting some of the products in Salesforce Industries. It's the only Salesforce DevOps tool that is specifically built for ISV style development, or the only open source DevOps tool that's specifically built for ISV style development. And it's in a small pool of tools that are built for that model of kind of package development. The way I think of Cumulus CI in the SFDX world, I get asked this question a lot, is Cumulus CI a competitor to SFDX? I actually don't think so. I see it more as an orchestration layer on top of SFDX, and it competes with Bash. So rather than scripts, you have a tooling product that you're defining the configuration in. And it has over 10 years of active development and active ISV use. We used it extensively at Salesforce.org. So it's a pretty mature tooling product at this point. So Cumulus CI itself has 4 main components. The core of Cumulus CI is its configuration engine, which is most of what we're going to be talking about today, just to show a couple of examples. It has an integrated keychain. The keychain stores orgs and services, so connection to third-party services like GitHub that you might need to run automation against. Tasks are the basic unit of work for automation in Cumulus CI, and then flows are sequences of tasks and flows I apologize for calling them flows. I apologize for that for years. They probably should have been named an orchestration or a recipe or something like that. They are not related to Salesforce flows, I guess, just to clarify. And then CCI is really a command line interface that's a client application of the framework that allows you to run the portable automation that's defined in the framework. So I said that configuration is the core of Cumulus CI, and this is absolutely true. If you want to understand Cumulus CI, one of the best things that you can do is take a look at the universal configuration Cumulus CI YAML for Cumulus CI. Let me go ahead and open this up here. And just to give you an example, this universal configuration, we're going to talk about in a minute here, a flow called dev.org. And you can see here the definition of the standard dev.org flow in the universal configuration. No magic, basic, simple, just a list of steps that are numbered. And all of the standard universal configuration is all defined in this one file that ships with Cumulus CI. So that's our best guess of what the best practice is that you should be using for any project. But we're obviously, that's going to be different for every individual project. So that's where the extensible part comes in. So think of the universal configuration as defining a common interface for doing DevOps on a project. Now, in your project config, in your project repository, you have a cumulusci.yaml file that overrides and extends the universal config to adapt it to your project, but keeps all the names and all the interfaces the same. So you're really providing or defining the implementation of the interface in your project configuration. And in addition to that, Cumulus CI's other kind of, we'll talk more about config here in a second, but just to cover the other kind of key components. The keychain handles secure storage of credentials and encrypted files. It's similar to SFDX. It can work with the SFDX keychain in many ways, but it can support more than just Salesforce orgs. So services are defined in the Cumulus CI YAML. There's a standard set of services that ship with it, which you'll find in that universal YAML file. And projects can define their own custom services. So say you want to integrate with Stripe, you can define a custom service and the attributes that you need to collect in the keychain to interact with Stripe. You can use the CCI command line, CCI org, and CCI service commands to interact with the keychain. So pretty simple, straightforward. Tasks in Cumulus CI, like I said, are the basic unit of work and automation in Cumulus CI. It ships with a ton of included tasks out of the box for a bunch of different things that we needed. We found we needed to automate in our recipes over the process. It's not comprehensive. It doesn't do everything, but it's extensible. So tasks are implemented as a Python class. So you can write custom Python classes. You don't have to for most of the stuff that you do in Cumulus CI, because tasks also support task-specific options. For instance, the deploy task has a path option that it accepts for the path of the metadata you want to deploy. And so you can configure all of those and build new tasks just in YAML without touching Python. But there is a rich layer where if you need some custom automation against APIs that's not handled by Cumulus CI, you can build your own classes and wire them in. Tasks are then basically registered in the Cumulus CI YAML file. So you can build new tasks like a task named deploy_site, where people don't have to remember the option flags. They can look up a list of the tasks by using CCI task list, see that there's a deploy site task in the project. They can use CCI task info to look at the info for that, task run to look at, or to actually run that task against an org that they specify. So basic way of building the building blocks of a recipe. And then flows are just named orchestrations of tasks. So Cumulus CI provides a common set of flows in universal config. The dev_org flow is kind of the standard flow. We just showed that definition in the universal config. It's just 4 steps, I believe. And then flow steps are numbered, and they can be overridden and turned off in the project's cumulusci.yaml file. And you can use, I have these commands wrong. This should be CCI flow list, task list, and task run. So the next thing that is a big part of Cumulus CI, and we saw it briefly in the demo that I showed for using Launchpad, D2X Launchpad. Cumulus CI was built for extension packages. We had to support them at Salesforce.org early on. Originally, when Cumulus CI was written in Ant, it still was written to support extension packages. That was painful. It's gotten a lot better and a lot more robust in the way that it handles dependencies. But the big thing is the build processes create artifacts and repositories that allow the repositories to be used as a dependency. So you just point at the repository as a project dependency defined in your project's Cumulus CI YAML file. There are also different dependency resolution strategies. So say you want to only install the latest production release of dependencies. Say you're building up a Scratch org and you want the latest beta release of dependencies. Or, as we'll talk about here in a sec, or later when we talk about the process, you can use 2GP feature test packages that are created by builds and then set on a commit status to look up or to build packaged versions out of feature branches. So let's talk a little bit about customization with the Cumulus CI YAML file. First, a couple of kind of design principles as you're approaching this. You have a lot of power at your hands as a developer because you have the power not just to put things in the package, but to control how they get delivered to orgs. So you need to think about how you're approaching building these recipes a little bit differently, because you need to design for production delivery wherever possible. Don't build a separate flow for dev and a separate flow for QA, a separate for demo, and a separate for production. Try to keep those unified as much as possible. That's easier by following don't repeat yourself kind of principles. Cumulus CI flows can be made to call other flows, so you can kind of componentize logic and work with it. Also use the defaults. This is well architected. It provides this advice of using the built-in functionality wherever possible. Really try to understand what Cumulus CI is doing and then how you can tweak it. There's a ton of flexibility and configuration. It's a lot like learning to build something on Salesforce, right? You have to learn the platform and learn what the platform provides instead of just rolling your own all the time. And last, start from scratch. Regularly rebuild your Scratch org to test the entire delivery recipe from scratch. So when we look at customizing a flow in the Cumulus CI YAML file, let's take this basic instance. I mentioned earlier, we want to define a task to deploy a site metadata or a site's metadata. And then we ideally want that site to live in every developer's org. So how do we adapt the dev org flow from the universal config to add that deploy site to the end of it? So up here on the left, you can see that this is the standard definition of the dev org flow. It calls a flow called dependencies, which is going to install any dependencies defined in the dependencies engine. Then it's going to deploy or run a flow called deploy unmanaged, which deploys the unmanaged package source. Then it's going to run a flow called config dev. And then this is actually a really cool feature. When it's done running all the automation, it resets source tracking. So from that point forward, you're capturing changes that you make through source tracking, but you're ignoring all the changes that are already automated through something in version control. So what you want to do in this case is add a third step to the config dev flow. And that is the example of that is over here on the right. You can see it's just adding a step 3 to the task deploy site. And then that task is defined here using Cumulus CI's built-in deploy task, specifying a custom path to the directory where we have the metadata. And I can provide a description here that lets people know when they use CCI task list about that task. So with that simple change, nobody has to remember some custom command. They come into they come into this project, they run CCI flow run dev org, and they get that site deployed into their org. They don't have to know the specifics of the project because the project has implemented the interface in the right way. So some of the other customizations you can do in Cumulus CI, if you don't like the opinions that are baked into the universal config, you can shut them off really easily. You set, if a step is set to a task, you just set the task to none. If it's set to a flow, you set the flow to none. And that will disable that step in that flow for that particular project. If you want to insert steps between others, step numbers are actually parsed like version numbers and compared like version numbers. So 1 to 1.1 to 1.1.1 to 1.2 to 2. And so you can inject values in. You don't have to do the basic like skip 10 numbers every time when you're doing steps. And you can also define conditional flow steps. So Cumulus CI uses Jinja 2, which is a standard Python formatting or templating language. It has a really simple expression format that's pretty easy to understand. It gets passed some different variables and information about the environment, and then can inspect that. And if it returns true, then that step will run. If it returns false, the step will not. In this case, if it's a scratch org, don't run this step. And as I showed a little bit earlier, all the tasks in Cumulus CI, and you can see examples of all the built-in tasks defined this way in the universal config that I showed earlier. All the tasks are defined basically just as a YAML structure with the task name, a description, a group, which is how they're grouped in CCI task list. One of the cool features of groups, by the way, is that if you define a new group for your project, it shows up at the end of the list. So if you say, my project config or post-install configuration, that'll be the last group that shows up when people run CCI task list. And the last thing here is that you can bake in the specific options that you want. So rather than having to tell people all the different option flags they need to remember, you bake the option flags into the project config into a named command that they just run. And a couple of other features of the Cumulus CI YAML. I don't want to go too in-depth on this, but I just want to kind of paint a picture of what's possible. I'll probably do future webinars that are deeper dives in some of these specific topics. So one of the really cool features is not only can you depend on another repository, but you can source in all of that project's Cumulus CI configuration. So you get access to all of that project's tasks and flows. In this case, I'm pulling in Salesforce.org's program management module. Just by pointing at the GitHub repository, Cumulus CI will parse the Cumulus CI config YAML, or the Cumulus CI.yaml file from that repo, and make all of its tasks available for me to run in the automation in the project that I'm building. This is huge for if you're building, if you want to get solutions engineers building modular demo configurations and reusing automation that you built in the project repo. So two quick safe harbor of contributions that I am actively working on. One of them is contributed, one of them I'm working on contributing, but I have working, which is this. Actually, this first one is the one that I need to contribute still. I will try to get this in sometime in the next month. But basically, for a long time, if you wanted something in Cumulus CI, you either had to write it in the project repository as a custom task, or you had to contribute it to Cumulus CI itself. What I've been working on is a simple plugin system for Cumulus CI, where you can build a Python package that has its own dependencies. So say you interact with Stripe and you want to create a Stripe webhook, you build a Python package that uses the Stripe SDK as a dependency, and has a Cumulus CI YAML that defines a task called Stripe create webhook. Then in your project, you would install Cumulus CI Stripe, the Python package, in the environment. You define the plugin as a requirement, and then you could call any of the tasks that plugin had created. So this allows kind of more modular community-built extensions of Cumulus CI, and is a feature I'm really excited about. The second is Load YAML, which is one that I built in collaboration and request with one of my clients, where you want to have a set of configuration that's relevant only in a specific context, and you don't want to put it in the main Cumulus CI YAML file. A good instance of this is if you want to have different logic to upgrade an org for a particular version number, you could store that in a file under the version number, and then load that YAML file from the command line when you need to. And I just discovered this and made this slide about 30 minutes ago. Released yesterday in Cumulus CI 3.4 or 3.84 is a really cool new feature that I think is should be talked about more. It is non-source tracked components, or the ability to list and retrieve non-source tracked components. So anything that is not tracked by source tracking in the metadata coverage report, this allows you to list those components and to retrieve them from the org, which is really, really powerful. And just a good example of Cumulus CI is continuing to evolve, is continuing to grow. Now, one last bit of Cumulus CI before we jump into process really quickly. is that there's a whole set of automation logic in Cumulus CI that's built around this concept that we call metadata ETL, or metadata transformations. So basically, this is about how do you safely automate configuration changes to risky metadata types, especially as an ISV. For example, how do you add a pick list value into a pick list that you don't know what values are there already? How do you add a field to a page layout that you don't know what's on the page layout already? That's what metadata ETL is kind of built for. And there's a whole set of tasks and a framework in Python in Cumulus CI to build these tasks that accomplishes a lot of these common needs that you would have. So for instance, to add a field to a page layout, you would define a step in a flow that's using the add page layout field. You specify the API name of the page layout that you want to add, the API name of the field you want to add, and you can give it a stack of position preference of where it's actually going to be located. So in this case, I want to put foo after the field pos. You can also automate adding a pick list value pretty simply in the Cumulus CI YAML. You just define the pick list values that you expect to be there. And these are doing an ETL style process. They retrieve the existing metadata from the org, they make their modification, they put it back. So it's safe to run against an org that you don't know what's there. I think these tasks are incredibly useful to ISVs and how you think about kind of scalably delivering some of this org setup automation. So just to recap, Cumulus CI provides that common interface to automate operations across all the projects for users and for automated processes. The way that D2X and the way that we're able to scale our build processes across many different products easily is because there is a common interface for projects to work with. So I'm going to walk through this diagram in more individual slides, but I want to kind of show the overall picture. This is a North Star diagram I created in August of 2022, so it's about a year and a half old, but it still holds. This is the vision of where I think that is the ideal kind of process for development all the way through delivery for ISVs in the most efficient way possible, leveraging the best of platform capabilities. There's also a blog post out on the Muse Lab website that goes into each of these sections in a lot more detail if you want to dig in. But first, let's talk about the development and QA process. So in this case, we are interested in making sure that all development work is isolated in a feature branch. And to do that, we have developers create branches that start with feature / and some name. And then they use the dev org flow to create their scratch orgs. And they modify the dev org flow as they need to modify how their feature that they're building in the package would get delivered to an org. So they're developing the full recipe there. Then there's CI builds on every push that tests the unmanaged and the managed versions of the code. You can tweak this based on how conservative you want to be about scratch org limits. Most of my clients just run the 2GP feature test build. That build is going to go and create a 2GP feature test version of the package. So that's your exact same package code in the exact same namespace, even if you're 1GP, in a totally separate package. And the versions are created with skip validation. So they create very fast, and then it sets a commit status on the commit with the information about the package. That means that anyone on the team, when that build completes, can spin up a new scratch org with a managed namespace 2GP version of the code that's in the feature branch and test it fully as a namespace managed package. That is a huge advancement, especially for a 1GP ISV. The other thing to point out there is if you're a 1GP ISV now, you're probably wanting to get to 2GP with the conversion process. Setting this process up now helps you start building with 2GP now and be ready for when the conversion happens and is available. And then the last here is almost all of your compliance is handled just by standard built-in GitHub functionality and protected branches that you apply to your pull request or to enforce all the compliance requirements in your pull requests. Then the release process, once a pull request gets merged into the main branch, as we talked about last week, that's the release subway. So we want to make sure the train is ready to leave the station at its scheduled time. So every merge to main triggers a beta build. That beta build, whether it's a 1GP or a 2GP package, then gets installed into a new Scratch org. Tags and releases are used to persist the information about that version. So one of the other things about Cumulus CI's release process with 2GP especially is you don't have to edit the sfdx project.json every time you make a release. All the release information is not stored in files. It's stored in tags and releases as artifacts in the repo. And regression is then done in a Scratch org using the latest beta. So we actually switched to this whole process at salesforce.org of not regression testing after creating a production version. But in order to do that, in order to test a beta, you need to be able to recreate your entire regression environment from automation that's in version control. And we hit that and we're able to do that, which allowed us to be able to test beta versions. What we would do is install the latest production release, upgrade it to the latest beta, and have all of the configuration automation in that org so that we could run an entire regression test against an on-demand ephemeral org. And then the entire process of release creation should be basically just an easy button, right? Somebody who is authorized to kick off the release, kicks off the release. All the checks are enforced to make sure that they are authorized to do that. And then from there, you want as much of an automated delivery pipeline as possible to create the release, to push it out to customers, to publish it out to your partners and implementation teams and things like that. So from there, from the release process, you really get into the delivery process. You look at push upgrades to existing subscribers. At salesforce.org, we did push upgrades every week to about 1,000 or 100,000 orgs. And push upgraded consistently to everyone. I cannot emphasize how much of a benefit that is to your overall operations and efficiency to do that. I know that it's hard, and I know that a lot of people or a lot of ISVs struggle with it. But the key thing here is automate the process of scheduling your push upgrades in the build pipeline. Don't have somebody go into an org and click around and schedule it. Automate that as part of the pipeline. Also automate updating your TSOs. Remember, your TSO is part of the path to production to customers, which means it falls under all the compliance mandates when you get audited. So having your pipeline run the recipes against the TSO to make the updates ensures that the recipes are defined and reviewed in version control before they ever touch the TSO. Oh, yeah, and an asterisk, whenever possible. There are some things that you'll need to do manually in the TSO at times, but try to avoid that as much as possible and automate as much as you can. And then one of the other pieces or kind of pieces of Cumulus Suite, which goes along with Cumulus CI, is an open source tool called MetaDeploy. You can see MetaDeploy out at install.salesforce.org. And that is basically a web-based tool for installing and running these rich automation recipes in order to install a product. Generally, you have a product. That product has multiple different plans for like a bare bones install, a full product experience install, maybe a demo install with sample data. And then you can build individual plans to allow someone to spin up a Scratch org from an attached dev hub that you provide. So if you want to allow your prospective customers to spin up a 30-day Scratch org and kick the tires, or even a 7-day Scratch org and kick the tires, you can do that. If you want to use this to enable your internal teams to do that, you can do that. MetaDeploy to me is the best example of portable automation because it's the same automation you built in order to run the development and QA process. And now you're applying that same automation out further in the delivery lifecycle. What that looks like in MetaDeploy, here's a screenshot. It's a little bit hard to see in the scaling, but that's because it does a lot. This is actually a real installer for Salesforce.org's grants management product that installs 3 different managed packages. The package itself does a bunch of post-install configuration, creates and configures and publishes an Experience Cloud site, sets up email templates. All of these things typically are in your post-install doc that's really lengthy, that's just screenshots of everything to do. In this case, it's already automated because we needed to automate it in the dev process. And so it's available for anybody to be able to run that automation. Now, the last bit on the kind of process diagram is how you enable extensions of the thing that you've built. So you can automate publishing of a subset of the recipes that you built for internal use out to a public GitHub repository that then your ISVs could point to as a dependency. So if you have ISVs that are building on top of your package, they could point to that public GitHub repository as a dependency and automatically resolve the latest version of your product, automatically leverage all the different automation that you've published to make available to them to make their own, to streamline their own development process on top of your ISV product. And this can be used for building repeatable solutions and demos and implementations internally. So that's the whole process. And the goal is to get that whole process, that whole product, that whole solution running through a common, fully automated and secure pipeline, so that you can build this architecture of composable modules that you can mix and match and reuse and compose together in every implementation project that you do, even going as sophisticated as running an implementation itself entirely through version control as a layer of composition on top of all of those, and delivering that to your customers as well. So you have all of that defined in GitHub, you've got all that process automated, and it's running. We talked a little bit about meta-deploy. I think, one of the challenges of meta-deploy is it's an open source tool and you have to run it yourself. So what we're looking at, and I want to just kind of briefly describe our product vision of what you're going to be seeing from MuseLab over the next 6 months or so, is it's already possible to set up all this rich automation and these recipes in your GitHub repository. The next phase of what we're building is MuseLab D2X Cloud. D2X Cloud is a cloud-based keychain for creating, connecting, deleting, pooling, and sharing orgs. It is a job system for publishing plans or recipes, and then running a list of steps against individual orgs. And most importantly, it's an API. So this is API first DevOps. The goal is to take all the automation recipes that you've created in GitHub and easily expose them to you through an Open API 3.1 API, so that you can use all the industry standard tools, and so that we can then build client applications on top of it, like a simple embeddable JavaScript play button that you can embed any of your published plans anywhere you want for people to be able to run themselves. Or a secure login URL to be able to get to orgs that people still have to authenticate using the D2X Cloud login, and access to the orgs is verified. Way more secure than sharing an SFDX auth URL. A new D2X command line interface for interacting with all of this. And most excitingly, bringing the DevOps user experience actually to where users are. So D2X for Jira, D2X for Slack, bringing all of the interactions and all those recipes that you've built directly to where your users or your internal users are already working. So if you have a QA that's working in Jira that is not used to working in GitHub, don't make them go learn GitHub and go work in GitHub. Expose a button to them in Jira that allows them to spin up a Scratch org, go in and conduct their tests, and then delete the org. And finally, for ISVs specifically, D2X for Salesforce. This allows you to build custom setup interfaces and LWC interfaces where you need to modify metadata. We know it's not safe and so recommended to do that directly from the Apex code in the package. So D2X Cloud provides a secure way, a secure backend for you to build the front-end interfaces and then run the automation that the front-end interfaces have defined through your custom kind of interactive UX with your customers. So that's the vision of what we're building. It's evolving quickly. If you're interested in this, certainly reach out to me and you'll be hearing more about it soon. There are a ton of resources available. I'm going to just highlight that they're out there. I'll share this slide deck out at the end or later today at the end of this call so that everybody can click through these links. But there's lots of great information about everything that I'm talking about here that's available to you. A quick call before we get into Q&A is I love talking about this stuff, whether you're a prospective customer of mine or not. If you're interested in talking about this, I love hearing what people have on their minds and how they're understanding these ideas and what holdups and reservations and things like that, where I might be wrong. Any of those sorts of things, go book an hour with me. I don't do less than an hour. It's just kind of my nature. And I don't know why that just exited. Finally, if you're going to Trailblazer DX, please come to my session. It'll be a theater session. I don't yet know on what day, but this is a session that I'm co-presenting with the director of Ron Forkes, the director of DevOps at RiskConnect, about the services engagement that I've been doing with them over the last 7 months to transform their process with everything that we've been talking about here today. They're the example of that 15 managed package process. We'll be talking about that and the things and the advantages that we got from it at that session. All right. That was a ton of content to go through. I hope that was helpful. Let me see where we are at on questions. Okay, there are no questions in Q&A. I have not been following the I've not been following the chat. So if there are any questions in chat, anybody interested in, I think most of you should be able to come off mute if you're interested in coming off of mute and asking a question. But yeah. Oh, yes. Great question from Julian in chat about the new snapshot feature and how it might make Scratchwork development possible for customers. I can go on a bit of a soapbox about the snapshot feature. I'll try to avoid too much of a rant here. I think that feature is amazing, and I'm super excited for it. What Scratchwork snapshots are, for anyone who hasn't seen this yet or heard about it yet, is you can have a scratch org where you make some configuration in the org and then you snapshot that org, very much like when you create a template of a TSO or a trial for source org. And then when you go to create a new scratch org, you specify the snapshot that you want to create the scratch org from, and that is the template that your new scratch org is created from. So say you have to have 10 managed packages installed and some unmanaged metadata deployed and some data loaded into the org. You can do all of that in the org and then snapshot it. And then all your future orgs would start from that as a baseline. There's two big challenges that I see in that. The first is I am fearful that people will look at that as a way of persisting manually done changes in an org, which would really be a shame, because the real value of snapshots is the ability to containerize a set of automation that is already run. So kind of like a Docker container or something like that. And so I worry that it could be misused in a way that trial for source orgs are often misused, I think, in a similar way, versus automating that as part of the pipeline. The other kind of question mark specifically for ISVs is that I'm unsure what the limits are going to be on Scratchwork snapshots. So, for instance, if you're an ISV that's building, let's say my client's example, they have 15 managed packages. And for each managed package, you would want to maintain a snapshot image that is, at the very least, just the dependencies pre-installed. And then ideally, the latest beta version out of main pre-installed and configured. So you have 2 snapshot profiles per project repository, 15 project repositories. That's where the limits start to get a little bit interesting in the ISV context. And I think something that ISVs should be, talking with Salesforce about and trying to understand is how is that going to be structured in our world? Because for a single customer that's looking at a single production org, they might not have the need for as many of those profiles. So that's my general thoughts on Scratchwork snapshots. They're amazing. And I'm really excited, in 2 weeks here, I get to actually play around with them, because they're actually going into a general availability beta, or I'm sorry, not general availability, a beta that is available to everyone instead of a closed beta. All right. We'll give it a few minutes and see if there are, give it a few seconds and see if there's anyone else.
Hi, Jason.
Yeah.
Question for you. I don't know if this is related or not.
That's okay.
It's around the build times for packaging. I'm just like kind of really struggling with like creating a fully validated package and code coverage and just sitting there waiting. If you have a package dependency on something like Health Cloud, it's an automatic 45 minutes. And like compared to like another tech stack, you just create a binary and then you maybe it's not that simple, but it's pretty.
Yes.
You just place it and then you're done. So I don't know if you have any knowledge of the inner workings, if that has a if there's a possibility that it frees up something in the future. But just wanted to see if you had any thoughts on that.
Yeah, definitely. It's a great question. So, and it actually correlates back to Julian's question perfectly. So perfect segue. I think of snapshots kind of like Docker in some ways. You should have an automated process that can build up the image that you want to snapshot. And if you do that, I believe I can't verify this, but I believe that it is true. That you can use I'm almost positive it's true, that you can use a Scratchworks snapshot as the build org image for a 2GP package. So when you create a validated build or a validated package, 2GP package, what's actually happening is a Scratch org is being spun up that's called a build org. That org operates like a 1GP packaging org and then gets metadata deployed into it, the manageability rules checked, and the package version is uploaded from that org. There is a 4-part blog series, I believe, that David Reed wrote about all of the details of this based on all sorts of testing and examples. That's really fantastic for understanding all the details. And that's my reference point for understanding it. But if you understand that basic fact that with 2GP, there's a Scratch org being spun up for you by the platform, your code gets deployed into it, and then the version is created using that org. Then you could see how if that org is spun up from a snapshot and that snapshot is readily available at the time you go to create the package, now all that package dependency resolution that you're talking about and the delay of getting all that installed goes away. So snapshots are huge in that sense. I'm really excited about them. I'm until I get my hands on them and I'm able to like really thoroughly test them and understand them. I'm not ready to say everyone should be using them, but I'm really excited about getting there because I think that's a huge part of answering the challenge that you're talking about.
That's awesome. Thank you.
All right. Anyone else?
Jason, you got another question from Julian in the chat there.
Oh, yeah. Okay, so if you're already using, so the question in the chat is, if you're already using a Salesforce DevOps tool, any thoughts on how to graft in Cumulus CI successfully? Couple of answers to that. The first is I just wrote a blog post about a month ago called Cumulus CI for SFDX and SF devs. And the whole point of that blog post was about how you can incrementally start approaching Cumulus CI and pulling some of the things in. The one thing that I would caution about that is it's very easy with that approach to just use Cumulus CI like a tool belt and not get the full, like the real value of Cumulus CI. So it can mask the real value of Cumulus CI if you use it that way. Doesn't have to, and if you're aware of that, potential, then you can mitigate that. But as far as integrating with other tools, CCI itself is just a Python command line that can be installed anywhere that you have access to be able to install things. So in GitHub Actions, You can easily install Cumulus CI in your builds. You don't need to with D2X because there's a Docker image that you can build on top of, but you kind of inherit all of that stuff. You could easily, it depends on what the DevOps tool that you're using is, and if that tool is extensible to allow you to install packages and run, new CLIs and things like that. If it's not, then that really is a huge part of the motivation that I have in building D2X Cloud, is if that's all available to you as a REST API, either other Salesforce DevOps vendors can integrate those recipes that are published by ISVs into D2X Cloud, into their user experiences, and allow their users to kind of sequence them and work with them, or kind of move on from there. I think, that's the other kind of hugely exciting part of this, is that right now so much of this is locked up in, so much of the automation is locked up in, you have to get a runtime environment that has the tools to run the automation. If we can get that automation that every ISV is building as part of implementing this process available for anyone to be able to kind of publish and run and integrate into their apps and their user experiences, I think it'd be way more powerful. So Matt has a question about meta deploy. I'll just go ahead and read this off. I'm wondering if the primary value add of meta deploy is, if any, to smaller ISVs, consulting groups, where new client org spin-ups and client upgrades are entirely handled by the dev team, not by a Salesforce admin on the client side. Any thoughts? E.g., is the pre-flight check feature of CCI only available when using meta deploy? I can't remember, but I think that there has been some progress lately on adding support for pre-flights or pre-flight checks earlier, or I know that there's been discussion about it. You can do pre-flight checks. You can do the equivalent of pre-flight checks with when clauses in standard Cumulus CI. But yes, I agree. It'd be nice to unify those two, and that's something I'm looking at also with D2X Cloud. So meta deploy, I think, is useful to anybody that has a recipe that they've developed that's valuable. We used it as a really large scale ISV to let all of our customers install this kind of rich tapestry of products that they needed, and metadata and packages and things like that they needed to get into their orgs at salesforce.org. I mean, I believe the last time that we publicly reported during my time there, we had run somewhere in the range of like 50,000 installs through install.salesforce.org. So there's, it is certainly something that can scale really well. The biggest thing is, if you have a recipe and you want to enable people to kind of bring their own org and run that recipe without having to install CCI on the command line and, go to GitHub or any of that sort of stuff. If you want to really expose that automation to everybody that could benefit from it, right now meta deploy is the best tool available to do that, and it's really good at that job. So yeah, hopefully that helps. Another example is another use of meta deploy is that at salesforce.org we worked with our solutions engineering team to build these modular demo packs. And then they published those demo packs that were built just using Cumulus CI and a GitHub repository. They published those demo packs to an internal meta deploy instance that all the solutions engineers could use to install into their demo. So if you wanted to go demo nonprofit cloud in France with a particular ISV installed, you could pick those two modules in meta deploy and run them against your demo org after spinning it up. And you'd get that configuration. So the demo org doesn't have to have everybody's config, and it can be modularized for specific demo instances. So there's a lot of utility to these tools. This session is really focused on ISVs. I don't see these tools as just ISV tools. I just think that that's the place where they're obviously of the most value. And I think that as we prove that case with ISVs more and more, we'll be able to then kind of extend that out and make the case with the rest of the ecosystem that, hey, this is a really good approach for you to consider thinking about how you develop a single production org. as a set of modular composable pieces. But I think, ISVs need this stuff to work and feel the pain of it now. So this is the logical place to kind of build it and solve these problems. Let's see, there's a question about, is it required to, Francisco has a question about, is it required to connect the Dev Hub to MetaDeploy? What is the purpose for connecting the Dev Hub to MetaDeploy? Great question. No, it is not required. If you hook a Dev Hub up to MetaDeploy, you can turn individual plans, you can allow individual plans to either install into an existing org where you do an OAuth connection to an org and run the plan, or where you can spin up a new Scratch org. So you could have a plan published on MetaDeploy that anyone could come to, or a select group of people that you limit to be able to come to. They can come there and spin up a new Scratch org that provisions a Scratch org, runs the whole plan against it. That Scratch org is coming out of your Dev Hub, but then they get access to the Scratch org that's created. That's really handy, for instance, because you can expose product recipes that are defined in GitHub that are internal to an external facing interface where people don't have access to GitHub, but MetaDeploy is kind of providing the proxy to expose that to them. I think Julian has a really great idea, which is we should consider creating a Cumulus CI service marketplace for people with Cumulus CI skills to match with organizations. It's a small and growing group of people that know these tools. There's lots of great people around in the ecosystem from kind of the .org era and beyond that have a lot of hands-on experience working with these tools. Part of what I'm excited about with MuseLab is being on the outside and being able to kind of collaborate and communicate with everyone. We are forming at the Salesforce.org open source commons community, Salesforce.org commons open source community sprint next week, or the week after. No, I think it's next week. At that sprint, we are actually launching a Cumulus CI Commons team in the Salesforce.org Commons with the goal of, excuse me. That's annoying. All right, there we go. So the goal of that project is really to try to build more of a community around Cumulus CI and kind of to collaborate. It's not to take over core development of Cumulus CI. Salesforce is still, actively working on that, and we can contribute to that. But it's really, how do we kind of build this network around Cumulus CI? How do we bring people together around it that have this skill set? How do we grow the skill set in the ecosystem? But I love the idea of a marketplace too. I would love anyone's ideas, because building up such a marketplace is not a specialty of mine by any means. So, all right, well, I think we've exhausted all the questions in chat. If you have any questions that you're still kind of thinking on after the session, I'll get a recording of this session up later this afternoon. That'll be public for anybody to be able to watch if you want to send it around. But, again, to reiterate, that Calendly link that was earlier, you can use that at any time to book a 1-hour session with me. We could talk about your specific details and questions at any time. So thank you to all of you for coming. This is really exciting, and I will see you all soon. We'll have, I am going to put a poll out on LinkedIn here soon for some potential future webinar topics. And I'd love your input on that. I don't want to just talk. I want to talk and say things that are valuable, or convey things that are valuable to you. So, let me know what's on your mind, what parts are still kind of fuzzy in your thinking about this. And, I'll continue doing these throughout the year. And with that, thank you, everyone. See you soon.